all present here in Rayat Shikshan Samstha's Yashwantrao Chavan Institute of Science, Satara, for the expert talk on artificial intelligence, cloud and edge, organized by Center of Excellence in Artificial Intelligence Applications, organized by YCCIII and Department of Electronics and Computer Science. So in the beginning, I request Mr. S.K. Shinde sir to introduce and welcome the chief guest and also introduce about the program.
Good morning all. Dignitaries for today's expert talk on artificial intelligence, cloud and edge. We have chief guest Dr. Ajit Zavkar sir from Oxford University. We have president for this function, visiting of our institute, Dr. Ghorpade sir, research team, Dr. Mujawar sir, head of Department of Electronics and Computer Science, Wag sir, all faculty members, dear students. We all know that artificial intelligence is buzzword for 21st century, and one famous book which is written by Yuval Harari, where he says humankind is losing faith in liberal story that determined global politics. In recent decades, exactly when the mergers of biotech and infotech combined with the biggest challenges humankind has ever encountered. So we know that there are revolutions in technology. From Stone Age to Silicon Age, human has developed, and in Silicon Age there is one technology related to computation, which is artificial intelligence, IoT, robotics are the buzzwords in Industry Revolution 4.0. And related to that, to confirm the technology, we have today's session on artificial intelligence, cloud and edge. And it is our privilege that we have eminent personality, Dr. Ajit Zavkar sir, with us. For sake of our chief guest, I shortly give about our institute. Yashwantrao Chavan Institute of Science, Satara, Autonomous Institute, and soon will become University. Karmavir Bhavarao Patil University. Our parent institute, Rayat Shikshan Samstha, have celebrated centenary year last year. We have 100 years in education. Founder of Rayat Shikshan Samstha, Convolutional Dr. Bhavarao Patil, established Rayat Shikshan Samstha in 1990 with one hostel, and now we have 750 higher education, 750 high schools, primary schools, and 43 higher institutes. We also have to scope up with technology. We last 2 years back we have established in collaboration with Tata Technology Center for Invention, Innovation and Innovation at Satara, Washington. Last year we also established Center for Excellence in Artificial Intelligence Applications, COE AIR, at our institute. So today, chief guest will give insight about artificial intelligence, and it is my privilege to introduce today's speaker, Dr. Ajit Zavkar sir. We all know that in Sakal you might have read their articles on artificial intelligence. He is author and course director, Artificial Intelligence, Cloud and Edge Implementation at University of Oxford, United Kingdom. He works in research, consulting, and academic, primarily related to applying AI for edge computation. And as far as his teaching and research experiences include Oxford University course director and teacher for artificial intelligence, as well as IoT, robotics, and MATLAB courses. At Oxford University, digital twins enhancing model-based design with AR, VR, and mixed reality. In Harvard Kennedy School, he is advisor in AI Society, Future Cities at University of Madrid, director of lab lecture on AI and smart cities. At London School of Economics, visiting professor for AI Masters in Business program. He also the chief AI officer of DGT GmbH in Berlin, Germany. Also on various advisory board, and he have also his personal firm, which is FinLabs, he is the director, where projects related to engineering, bioinformatics, cybersecurity, and healthcare are going on. Prior to AI, he involved in mobile telecom IoT since 1990. In 2009, he is nominated to the World Economic Forum Future of the Internet Council. Worked at Liverpool Smart City projects. Also passionate about teaching data science to young people like you, and this is our privilege that we are listening from him. As far as his education is concerned, he completed his doctorate of philosophy from University of Politecnica in Madrid, a master's in University of Salford, and graduation from University of Mumbai. So our chief guest have vast biodata for sake of audience. I use few of the. With that, I request Honorable Dr. Ajit Zavkar sir to please accept our invitation for today's expert.
Thank you so much, sir. According to the description you gave, we have a very eminent personality today for the lecture. So now, before proceeding to the talk, we have just a short clip of CIII that we'll see, and then we'll proceed with the further program.
In 1919, Padma Bhushan Karmavir Bhavrao Patil, through his sincere efforts, established Rayat Shikshan Sanstha, which has served as In 1919, Padma Bhushan Karmavir Bhavrao Patil, through his sincere efforts, established Rayat Shikshan Sanstha, which has served as the pillars of support for the education and social system of Maharashtra since the past 100 years. In the centenary year of establishment, the Sanstha, in its capacity as Asia's largest educational society, has received financial support from Rashtriya Uच्च Shikshan Abhiyan, RUSA, under its Entrepreneurship Development and Skill Hub. This has led to the establishment of Yashwantrao Chauhan Center for Invention, Innovation and Incubation YCCIII in the premises of its autonomous college, Yashwantrao Chauhan Institute of Science, Satara. The YCCIII in YC Institute of Science Resource Development Minister of Government of India, Honorable Shri Prakash Ji Javadekar, in the presence of the President of Rayat Shikshan Sanstha, Honorable Shri Sharad Rasa, also received support from the Corporate Social Responsibility Fund of Tata Technologies Private Limited, Singapore, in the form of technology support, equipments and softwares worth 18 crores. The central objectives of YCCIII are to bring new ideas to reality, to impart technical and non-technical education through various courses, and to help innovators to develop new products. The mentorship, guidance and support regarding patents, copyrights, design registration and marketing to the upcoming entrepreneurs. All the activities of YCCIII would be under the regulation of RUSA. YCCIII Satara consists of an advanced manufacturing center. The high-end workstations and softwares at the Technology Research and Development Center would not only facilitate innovators to transform ideas to industry. This would provide new opportunities for innovators and students to enter the fields of design, research, verification, and validation. The center will provide 6 courses. A few of these softwares and models are CATIA V6, MSc software, Adams Car, Feast analysis software. The Advanced Manufacturing Center would enable their ideas into prototypes and physical products. The candidates will also be given hands-on training for product design and development through the following utilities and instruments models. Sports Utility Vehicle Working Cut Section, Automotive Electrical Wiring Setup Demonstration Kit, Electrical Vehicle Demo Kit, Commercial Vehicle Rear Axle, High-Speed Transmission System, IC Engine Working Model, HVAC Working Model, KUKA Robot, VMC Machine, Ultimaker 2 Plus. 3D printing is an essential requirement for computer-aided manufacturing. Ultimaker Cura is a print preparation software which supports various types of materials and is easy to use. At the YCCIII, the trainee will get to learn and use this high-throughput all-round 3D printer and software. Red Shikshan Sanstha shoulders the responsibility with the 2 leading technology organizations of India to meet the objectives of YCCIII at very nominal fees. At YCCIII, a project in the field of automobiles on digital speedometer completed by a Bachelor's of Engineering student, Ms. Meenal Kolekar.
Today I have successfully completed this project because of CIII as they have guided me a lot and given me opportunity to work on this setup.
It proved to be a milestone in the field of 4-wheel vehicle industry. The patent process for this technology is nearing completion. Also, Sushant Rajge, after his bachelor's in engineering, has recently completed a course on product design and development.
In that course, a lot of things are known. We know like robotics, machining, and design. In the design, AutoCAD, CATIA are all the softwares used. And in the course, we know full knowledge of assembly, sheet metal, and part design. And the faculty of that course is very helpful. Thanks for faculty, and due to that course, our resume is very strong and this is helpful for our future. So thanks for RUSA, Red Shikshan Sanstha and Tata Technology.
Now I request Honorable Dr. V.M. Gorpade sir, PG Dean, to felicitate Honorable Principal Dr. P.T. Sadhu sir. Honorable Head of the Department of Electronics and Computer Science, Mr. J. Vaxon. Now I request Dr. Ajit Zavkar sir to proceed with this talk.
I just want to check one thing. When I present the, can I change slides?
Yes.
Slide person. Next. For some reason, I have a different slide deck. So I think what I'm going to do is I'm going to present you what this thing. This is slightly longer slide deck, but I think I'll present you some parts from there. And good morning, thank you for inviting me. आणि मराठी सोबत विषय टू इंग्लिश आणि दुसरी गोष्ट म्हणजे की हे जे मी what I'm going to present you is what we teach at Oxford. And what we cover AI and H. I have been involved, as you can see. We have been teaching at Oxford AI and Edge computing since about 2017, and before that, we were working 2014. This is a very complex subject, and that is why it's hard to cover it in this duration, to cover artificial intelligence and Internet of Things. But we have been involved in this subject primarily from a couple of areas such as robotics and things like that. So just a bit of my background, and most important thing is that I have a very strong industry background as well, including cybersecurity and things like that. So I've kind of brought up this idea of like strong. And the thing we are trying to do here is essentially that when you look at AI as a subject, yes, what we are seeing at here is that it is like those Russian dolls. Yes, you have one thing and inside. There is a complex subject which you have to master many things. The first important thing is artificial intelligence, and the second important thing is Internet of Things. Yes. So from our point of view, we look at a full stack AI course. Yes. When you say the word full stack, you mean everything from cloud computing to edge devices and everything in the middle. And then on the horizontal side, I don't know how technical or what you guys are doing, but it is mostly what we try to do is put AI into Docker containers and put Docker containers on edge devices. Yes. So we do the whole ML ops. Okay. So combination of data science, data engineering, data science, and DevOps. Yes, so this is how we see the world. And in that sense, it's quite a complicated picture. But of course, we are Oxford, and this is what we are trying to do always. And also, we are strongly focused on research. So what we are trying to do is create a whole philosophy around how AI and cyber physical systems work. Yes, when we took a look at this idea, we combined AI with systems thinking, with design thinking, with edge computing, and then trying to effectively try to understand how autonomous systems work with that. Right? So we are associated with the group which is a part of the autonomous vehicles in Oxford. So we are, as one of my colleagues who is German, he was actually involved in the Mars rover, and he worked in Death Valley in America. So it's the closest place on Earth which is close to the moon. So he actually tested out his robots in Death Valley. So in many ways, I think what I'm trying to tell you is that AI is a complicated subject. It's hard to cover it in this duration, but some key ideas we can take first. And the first one is this idea that when people think about artificial intelligence, they think about Schwarzenegger sort of combining and taking over the world. But what we see is a very clearly sort of different things. So basically, machine learning is when you train an algorithm with some data. Deep learning is automatic feature detection, which I will explain more. AI is machines that can think and reason, which are based currently on deep learning, but that also is changing because because there is some question about how deep learning algorithms and so on. Or then there is narrow AI, is what we see today, is basically AI to one particular problem and finally general AI, which means more like Arnold Schwarzenegger, meaning the Terminator movie, where AI can operate into many different areas, right? So at the moment, this is not, yes, we have one with the closest exception of GPT-3. I don't know, has anybody heard of GPT-3? GPT-3, there is it gives me an idea to see what you guys follow, which is very interesting. So we follow GPT very strongly. There's a very interesting algorithm. I won't call it an algorithm. It's called large language models. When you train these algorithms on very large data sets, and they have become very strong. They have become almost like they can write code, they can have conversations. We had a demonstration in Oxford where we had a group, and they were working with us. And the idea was that if you have a group of 5 people, yes, like Mr. Shinde was saying that this UR Hariri is vision of sort of where AI is going. So if I have a group of 5 people, and one of them would be not real, yes, would be AI, correct? But the point about this conversation is that the person who is AI is not subservient. Subservient meaning is not supposed to do what you're told, but can be independent. So the way we designed that experiment was that we had a group of people who are story writers. They were writing scripts for Netflix, for example. This was in Carbondale out of Illinois, in Chicago. And they are collaborating with us. But they didn't know the technology, so we helped them to build the system. But the thing is, if you are writing a story, if you're writing a script, yes, I'm trying to create something, you are trying to create a character, we are talking, yes. Now, instead of having you as a real person, you are a real person, of course, I know, but we can say that you are AI, right? And this was the real system because this is essentially GPT-3, which is a very interesting algorithm I'm talking about. And when you talk to build this story, it gives you feedback real time on how the character should evolve. Yes, so the point about this is that very soon, as we were talking in the introduction, you might find that you are dealing with somebody who is not real, but is not doing your job. At the moment, we define AI as, do what you're told, but this is not the world which we might well live in very soon. And this is what I wanted to demonstrate to my students in my class, and this is what we did. And another very interesting experiment we demonstrated was with the ADC biology group. It was with Sakal. But then what we tried to do was to try to combine augmented reality with AI. So this is a classic case of how you can do AI and edge computing. So in that case, what happens is that the model, which is the algorithm and the data, is trained in the cloud. It is created as a model. It is deployed to an AR headset. Yes. So the farmer goes and sees something in the field, and he or she sees a plant, and then that person is able to give real-time feedback whether there is something wrong with this plant or not on your augmented device. And this is the sort of experiment which we were very interested in, and we continue to build on that. The point about all of these things is that there is no real structure for it. Yes, so there is no real simple way of saying that this is how it works. Rather than we are taking these different technologies to AR, to model things, something else, API, and we are trying to combine them with AI. Yes, so we are launching, as soon as I go back to London, we are launching something on the AI and content computing. Correct? So my point is that again, I'm not an expert in content computing, but we have others who work in Oxford, and we collaborate like that. So we create these universities. We are collaborating, building something on AI in the metaverse. Again, we are trying to build different worlds in the metaverse and trying to simulate how things work. So this in my mind is my first initial step of saying what AI and edge computing work. And the principle is that you have something which is broadly in the second two definitions there, a deep learning algorithm. And what we are trying to do with the algorithm is train the algorithm in the cloud with some data, and then deploy the algorithm onto edge devices. Now, an edge device can be anything. Yes, it can be the AR headset, it can be a car, it can be a ship. With your autonomous vehicles, it can be a car itself. And therefore, the whole spectrum of what is possible with AI and edge and algorithms is extremely powerful. We in Oxford have been working on it now. I have been working on it for almost 10 years now, which is a long time. And that's all we do. We don't do financial services. We don't do insurance or anything like that. They're completely focused on AI and edge computing, which is to a large extent, if you look at the AI market, it's a little bit of a niche. Because everybody wants to work in the investment bank, everybody wants to earn a lot of money. But I like working with plants and cars and things which are tangible, and you can see some benefits to that. Okay, I will take some questions now. Any participant? We'll just wait a couple of minutes for questions. Anybody just want to raise your hand quickly, and if you have any questions or anything so far, or in general about AI. Yes. No? One person? Okay. We might try later, unless you have something. If you have something in the list, it's not me, and we can discuss that. But I think I like to keep it interactive because I think it's very important to keep it interactive. If you have any questions or any thoughts, we can stop at the questions. So this is the first idea I wanted to share with you. The idea that when I see the world of artificial intelligence, this is how I see it. It's a bit important to know that because sometimes the media hypes things so much that you don't know what is real and what is not. Yes. And so for me, this is not real. Yes, the Arnold Schwarzenegger stuff is not real. But what I'm talking about is building machine learning or deep learning algorithms to solve real problems. Yes, real things to work. So the next thing I want to share with you is typically this is the flow of AI. Correct? You build the data, you train the model, you take the model, and you see it on some data which you have not seen before. Correct? So this is the standard flow of any machine learning or deep learning algorithm. But in case of deep learning, this changes quite a bit. Yes, because in deep learning, you have a neural network. Neural network is designed to work in the brain. And in the neural network, you train it with various images, for example. Yes, and this is what we did when you look at the plant situation. You train it with various images and use it to detect something you have not seen before. For the bottom one is a picture of a dog which has not seen before. But a significant thing about this is that we are using the algorithm to detect the features of something which it has not seen before. And I will explain to you what this means. So if you think about the idea of traditional programming, yes, versus AI, yes. For traditional programming, you have to specify all the rules, right? You have to specify your if, then, else statement, and so on and so forth. And from that, you get some sort of outcomes. Yeah. But in artificial intelligence, you specify the data and the outcomes, and it is supposed to understand the rules. This is a very important and very subtle distinction, because what actually happens in the machine learning, you don't know what the rules are, but if you show enough examples of something, it can determine what those rules are. Yes, so this is the bottom line. And when I go back to the picture of the dog, which I had before, I'm skipping some slides because I think when I go back to the picture of the dog here, what we are seeing here is that we are showing lots of pictures of dogs and cats and skunks and so on. But it's able to detect what a dog is next time. And the way it does that is because it is able to detect what are the features which make up a dog. Okay, so this is what I mean by the definition of deep learning, as automatic feature detection. And why does that matter? Now let us come back to the idea of the rules here. Yes. When I said that we are trying to find out rules, there are certain problems which are very useful for AI. Yes. For example, if the problem is very large, if the problem is open-ended, the problem changes, the problem is hard, the problem has hidden rules, the problem hierarchical rules, the problem with many hierarchies around the code, or the problem is different. So these are the type of problems. I'll give you one example of what I mean by these, but these are the type of problems which deep learning solve. And they are hard problems, they're not easy problems to solve. And I will again explain to you with an example. So coming back to the question that AI is ultimately supposed to determine or find out hidden rules behind something. Yes, so if you understand that concept, next question is, The next question is basically the background in which it comes to is similar, correct? So if you look at the statistical background, and some of you are from statistics areas, so the statistics algorithms are similar with AI. So for example, you have the classification, regression, attributed form, ground detection, clustering, etc. Yes. So those things do not differ from what you learn from statistics. Yes. What differs is the way you apply it to artificial intelligence. And the way that works is in all these algorithms, you are effectively specifying what the features are for the data set, correct? So for example, if I want to say the prices of houses, yes, I will say that the price of a house is high if it is for 3 bedrooms, if it's in a good area, if it's near a good school, etc., etc. Yes. So those are the features which make up the price of a house. And what you want to say with AI is that it is automatically able to detect not only the characteristics of the data, but also the features of the data. Yes, so this is the key distinction when we look at artificial intelligence algorithms. And I'll explain to you why that matters, which is why it is different from traditional statistics. In statistics, you actually tell what the features are, or you do your statistical analysis of goodness of fit, stuff like that, or to define what a particular statistical form is. But AI, machine learning, deep learning algorithms effectively do that for you. So why does this matter? If I were to take a little bit of a step back, so who remembers what is this? What is the equation of this? Yes, good. Y equals to mx plus c, correct, yes. In this c equals to 0, therefore it equals y equals to mx. It's the equation of a straight line. Yes, the standard mathematical equation. Right. So if you look at something like this, the term on the right hand side, yes, you are not able to determine what the equation of that is, correct? Because there is no discernible relationship between the x and y. Yes, but the power of deep learning is that given enough examples, of course, given enough computation, given enough examples, it is able to determine what a hidden function fx is. Right? So this is the power of it. That can be C, that can be an autonomous driving car, it can be anything. Yes, and this is the power of AI. That is able to determine a hidden function behind the relationship. And in the end, it's all about mathematics. Yes, because if you look at what is a neural network, the neural network is simply a series of weights and biases, which are a series of numbers, which are sort of compounding with each other. And then you have an algorithm like back propagation or gradient descent, which helps to do it. Does anybody work with something like this, back propagation or gradient descent? Is familiar with it? Yes. Okay, good. So one person is familiar with that. That's interesting because again it gives me to what extent you guys are familiar with that. So again, with Oxford and many of these things, very algorithmic. So we spend a lot of time with these algorithms and try to find out how we have to run this. So when you look at anything like TensorFlow or Keras, does anybody know what TensorFlow is? Keras, TRS, Keras, you would possibly know. Yes. So generally those are libraries. Yes, so TensorFlow is from Google, and Keras is the library built on top of TensorFlow. It's all in Python mostly. Yes. So what that means is we tend to kind of all these algorithms are implemented in Python or R or some such language. And what you end up doing is either implementing them as they are and training them or changing the nature of the algorithm. So this is really where a lot of the AI world works in that regard. But the bottom line is trying to find out the hidden function effects. And this is generally the way we're trying to find out hidden function mapping relationships. And why if you put that in the bigger picture, so it's similar to mathematical modeling. Yes, in mathematical modeling, what you do is you have a real world problem, you create a real world model, you create a mathematical model, you draw a conclusion. With machine learning, you extend it onto sort of data which is trained. Yes, with deep learning, you extend it such that you define both the data, both the features as well as the characteristics of the data. Right? So each of these steps are sort of building up on each other based on that. So I will skip this section, which is quite long. What I want to show you is why why it matters. Yes, so I talked to you about rules and training and so on and so forth. I'm trying to give you a simple example of how AI is significant, why it's significant, why when we talked about you and Haredi, why does that matter so much? So the significant thing is that if you were to train an algorithm using data or tell it exactly what to do, it's actually a very limited number of things you can do. Yes. If you look at, for example, this picture, the one on the left-hand side is chess. Yes, IBM's Deep Blue defeated Gary Kasparov, I think, in 1999 or 2000, something like this. And the point about that is that problem of chess was easy for a computer to solve. It was easy for a computer to solve because the world of chess is a finite domain problem. Yes. What do I mean by finite domain problem? Finite domain problem means that it has 8 by 8 squares. Each of those pieces are behaving in a specific way. For a computer, it's a permutations combination problem. Right? If you have 8 by 8 and beyond that each of those pieces are well defined, then it's mathematical computation problem. And that therefore it was easy for computers to solve. However, it is not compelling, it is not interesting because most problems are on the right hand side. Yes, and even a child can find out what that is at all, right? But a computer cannot because there are too many variants around the concept of the word dog. Yes, you can have an obsession, Doberman, Basset, Wolfhound, a dog that big, a small, a Chihuahua. You can have big ears, small ears, long tail. So I like dogs. I can talk about dogs all the time, but the point is that within the concept of a dog, there are many variants to that idea. Yes, and therefore a child can determine that that is a dog, but a computer cannot because it is not a finite domain problem. A finite domain problem is like chess, where it has the world of chess has a boundary, as the world of real life does not have a boundary. There are too many variations. Therefore, what can AI do to solve this problem? And the way AI solves this problem is like how a child, exactly a child. The way the child solves the problem is to determine what are the features which make up a dog, first of all, correct? So the features are it has the long ears, it has fur, it is friendly, and so on and so forth. And the way AI works bottom up. Yes, and this is a very nice diagram I think from a book Joshua Bengio. And the bottom line is that the way AI works is that it looks from the bottom up and tries to find out what the roots are. So the lowest level of this picture, if you want to determine, to show many pictures like this, the lowest level is the pixel, right? The one above is the edges. The one above is the contours of the subtext, the goggles and stuff like that. Yes. So each layer of the neural network is finding something, and the subsequent layer of the neural network is building on what it has found before, right? So you do this over time, bottom up, and it ultimately, when it comes to the higher levels layers there, it is able to find out what are the features which make up C. Right? Now, obviously, not from the one picture. Yes, it has shown many pictures, and this is what I mean by learning by example. And if you're able to do that, then AI effectively will understand what this is. Of course, it still has to be trained, and that's where those two algorithms like backpropagation and gradient descent come into play. That's a slightly more complicated problem, but the idea is simple: that you are having a neural network which looks like a brain and which learns by layer from bottom up and is able to understand the features and specifically able to solve problems which are not finite problems. Yes. And that makes all the difference because then you can apply this idea not just to cats and dogs, but to tumors. You can apply it to cataracts. You can apply it to COVID X-rays. This is why it's such a powerful technique which helps. And this is just a basic neural network. Yes, and now we have LSTMs, we have GANs, we have reinforcement learning. So this is how I spend my time in teaching all of the sort of variants of the core AI architecture. And to me, I think that that's what it makes AI a fascinating field, where the rate of change is extremely powerful, but it's not very different from trying to find out It's not very different from trying to find out effectively a hidden function between x and y. Yes. So no matter what the function is, in this case, the function is determining the picture of a woman. Yes, it's a hidden function. I don't know how this function works, but I have enough examples of that characteristic, whether it's a cat or a dog or something like this. And given those examples, AI can learn what those features are and can understand what is inside now. Okay, any questions for now before I switch then to how are you doing for time? How much time have I got? Okay, so how much time more have I got? Half an hour. Okay, that's fine. Good. Then I can cover. Okay, any more questions? Any more questions on this one? Yes.
So you have mentioned about algorithms and mathematical terms. So we have students and faculty from mathematics. So how they start in algorithms and how they start for learning AI?
Sure. So this is the course I teach at Oxford, and a module I teach, and I really like it. So if you who is in math and statistics? Very okay, okay. Yeah. So essentially, there are four things which are related to AI and math and stats. One is linear algebra, second is statistics, third is probability, and fourth is optimization. Right? So if you look at those four things, linear algebra is primarily responsible for essentially putting everything into a linear set of equations, which is what you end up solving with a deep neural network. Yes, you can traditionally solve a set of linear equations using matrix inverse. Right? You can solve a set of linear equations using that, but in a deep learning or machine learning setting, the AI effectively, the whole of the neural network is modeled as linear algebra and a set of nested functions. So to solve a set of nested functions, if you take a derivative of a set of nested functions, you use the chain rule effectively, right? So the chain rule, so the whole of the neural network is a function within a function. So when I show those last layers with the top layers, so each of those them is a nested function. So this is the function inside. This is the function inside this. This is the function inside this. And when you do effectively the whole thing that you model as a series of nested functions, you take the derivative of the nested function. So this is how the whole neural network can be sort of looked at, and the derivatives are the gradients. Yes, the gradient is the slope, and that's why you do gradient descent, which is the algorithm to optimize them. So instead of solving the linear equations using a set of inverse matrix inversion, what you do is you optimize those linear equations using gradient descent and an algorithm called back propagation. So between the two of them, what you do is you find out the loss function for the whole neural network, and this is the total loss function here. And then you propagate the loss function backwards, the loss backwards, and at each of the neurons, you use an optimization algorithm for gradient descent, which minimizes the loss, and therefore collectively you minimize the loss to the whole network. That's how the neural networks and the maths work. And that's how those two things work together. Any more questions? Yes.
So how does the facial recognition works with the twins? Which features we extract for the twins?
For the twins?
And which twins? And which algorithm is best for this?
Yes. Okay, good question. So the basic way of determining anything to do with images, which is the image of a twin, would be convolutional neural networks. So the convolutional neural network is a variation of this one. Same thing. This is called a multi-layer perceptron, MLP. The second variation is called convolutional neural networks, which of course we don't have here. But what it tries to do is that when it's trying to analyze the image, for example, of a face. Yes, it tries to look at each section as a small matrix and tries to identify which features are there. This is how it finds out what a particular list for it. Now, the question about twins is interesting because from a computer's point of view, they would in principle be the same. Yes. But there's a bigger problem around whole facial recognition thing because of all the more dark side involved in that. But in a sense, from a computer's point of view, if they are completely identical twins, they would not be able to distinguish because it is exactly as I said here, because it would do the same feature recognition without. And that's math.
आपण फेशियल रिकॉग्निशन यूज केलं तर आपण ट्विन्स आयडेंटिफाय 100% नाही करू शकत. मग डीएनए रिकॉग्निशन केलं पाहिजे तर त्यासाठी
आता तर फेशियल रेकग्निशन मध्ये ते ट्विन्स पूर्ण आयडेंटिफाय नाही करू शकत माझ्याकडे. आता जर तुम्हाला अजून त्याचे आयडेंटिफिकेशन करायचं तर देर आर मोर कॅरेक्टरिस्टिक्स. आता आवाज असेल तर दिस इज अ मल्टीमोडल एआय म्हणजे आवाज हा जो वेगळा थोडा असेल कॅरेक्टर त्या कॅरेक्टरिस्टिक कारण फेशियल रेकग्निशन ही एकच कॅरेक्टरिस्टिक आहे. आता तुम्हाला दुसऱ्या कॅरेक्टरिस्टिक्सवर कंबाईन करू शकतो. आणि आता एक्झाम्पल म्हणजे आता तुम्हाला फॉर एक्झाम्पल एक एक्झाम्पल एआय चं मी वापरतो कधी तर तुम्हाला सपोजिंग यू आर गोइंग टू अ रिलेशनशिप काउन्सिलर. Yes, so you and your wife have some issues. You go to the relationship counselor, and the relationship counselor traditionally will ask you a series of questions. Yes, this and that, are you doing good? Are you taking care of her? Are you taking care of the night, and so forth? And the same question you ask your wife for this. But with AI, if you want to solve this problem, you would do it in a different way. You would then ask the two people to speak with each other. Yes, but the point is that there is a signature to emotion. Yes, there is enough examples of couples who are in love, and if they say I love you, yes, so there is enough signature for AI to detect that this couple is in love, and this is how they say the word I love you. But in this case, if they are not quite in love, and if they are saying the words without actually meaning it, so there is a second signature qualifier. So the short answer to your long answer to your question is that you would use multimodal AI. And DNA might be one of them. But because DNA is a direct distinction. And if tomorrow the DNA is different, then you don't need AI. Correct? Current tomorrow the don't signature don't have DNA is then why do you need another thing? So that is why AI is one portion of it when you don't have the exact answer. आता हे जे त्याला डिस्टिंग्विशन स्टोकॅस्टिक अल्गोरिदम आणि डिटर्मिनिस्टिक. आता डिटर्मिनिस्टिक आहे आता तुम्ही म्हणाल वाय टेम्परेचर सेल्सियस फॅरनहाइट असो डिटर्मिनिस्टिक अल्गोरिदम ऑलवेज यू हॅव द एक्झॅक्ट आन्सर. पण स्टॉक प्राइसेस इज स्टोकॅस्टिक कारण त्याचा इट हॅज टू मेनी व्हॅरियंट्स आणि यू कॅनॉट एक्झॅक्टली से जर स्टॉक प्राइस एक्झॅक्टली डिटरमाइन करायचं तर पीपल विल मेक अ लॉट ऑफ मनी. But there are too many variables. So you are taking a number of features and trying to get a model which may be accurate to a certain extent. But this is AI is primarily a stochastic. Thank you. Yes.
In case of face recognition by using iris, so we'll be able to find out the twin by scanning iris. So do we have any scope in the research for that? By scanning iris to find out the twins.
Okay. So the question is, do you find out twins by scanning the iris? So from a scientific point of view, I don't know if twins have the same iris. That is my first question. That is the last in my knowledge. Assuming they are different, assuming they are not the same, then it is very easy for AI to detect. Because for AI, it is a straightforward. It's the same like when you go to the airport. You in the US, you definitely do that. Maybe not in India, but you do this. IoT, yes, you stand in the UK also. You come to there is no immigration process. Yes, you come and stand there and look at this thing. Yes, and then it takes this thing and goes in from your eyes. So if they are different, then definitely. In terms of research, I think if they are different, then definitely 100% I would think there is some research around that. I don't know the scope of it, what is the want cyber security, for example. Okay, so cyber security, then you start to work into those areas with that. There are some elements there. I'm on the board of a sort of a New York Israeli cybersecurity company. There again, they look at what is called they look at hidden patterns which people are not exactly telling about. And there you can find out, again, it's a multimodal AI. So there was no more question. Yes, sir. Yeah.
Sir, is there any standard rule or function to decide the hidden layer or hidden nodes while structuring our AI?
That's a very good question. Again, it's a very common question. So the question is, how do you determine the nodes and the depth of the node? In general, the more complex and hierarchical the problem, the deeper the neural network is. Now that makes somewhat sense, because what are we trying to do here? We're trying to determine features, and those features are hierarchical, correct? So there are two eyes, and the two eyes are inside the face. Yes, there is headband. The headband doesn't go on your hand; it goes on your head, correct? So all of those groups, once you start to determine, the more complex the more hierarchical groups are, the deeper the neural network is. In general, as a general. Now there are many optimizations to this, and there are very completely different variations. So, for example, people use something called transfer learning. Okay, so transfer learning means that you train something. If I want to detect apples and oranges, yes, I train it using apples, but an orange is about 90% like an apple. Right? So then I use much of the lower layers which are used to train an apple, but only train the last layers to train an orange. Yes. So in this case, I'm kind of piggybacking on an existing neural network, which is not for my purpose, but it is a similar purpose, because apples and oranges, let's assume that they are 70% similar, 90% similar, and then we define what the difference is. Cool. Okay. Yes.
Can we do one thing? We are testing the X-rays of the heart and X-rays of the kidneys in case, or X-rays of any disease, any of our body part. And can we do with the help of image processing that detecting any diseases for heart failure or for kidney failure or liver failure? Can we do that with the neural networks basic functioning and the change in the functioning of the heart or kidney? Can we do that with the image processing?
Oh, good question. So there are two different things. There is image processing, right, which is just understanding what an image is and working. And then there is the applying of neural networks to understand what is inside the image automatically. Right? Now, one of the reasons why neural networks work well with certain types of problems is there are examples of that type of problem. For example, cataract. Cataract is a classic neural network problem because you have lots of pictures of eyes and you have lots of pictures of eyes with the problem. Similarly, lung cancer is also the same thing, or something like tuberculosis or something which is a respiratory. If you have a normal lung and you have an abnormal lung, and then you get a lung. Now, heart disease in general, if it can be tried scientifically for specific characteristics which can be detected, then yes, it is possible. But in general, blood flow and things like that do not hit, because there is not enough way to train that neural network to detect a particular feature. Yes. So if somebody, but the thing is with AI, you find every crazy thing every 2 months, every 2 days, you open something, you find somebody, people have done amazing stuff. So like Google did this plasma, I don't know whether you know this fusion reactor. So Google was able to simulate the working of the fusion reactor within DeepMind, which is a part of Google. And they were able to reduce the process of nuclear fusion using that simulation. Okay. So the point is that there are different ways of solving that problem. Not necessarily by looking at pictures, maybe by simulating the behavior. I don't know whether you have heard of a genetic algorithms and stuff like this, which are more like dynamic algorithms, where you start with a state and ask it to multiply or to interact and try to find out a particular state. Yes. So if I were to learn that something, that if I were to say that I have this is the normal state of flow, that with some sensors, and I then try to simulate the behavior flow of the body. And from that I can identify something which is not suitable. And trust me, there is a lot of people doing this. People are doing amazing stuff with it. And that's power of AI because it's a very generalized technique. That's the main thing I wanted to share with you at this point. That this thing is a very fundamental concept, but it applies to so many different areas that you get essential, learn so much. So, yeah.
Actually, I have a question related to applicability of ANN, artificial neural network. Suppose I train the neural network using some simulated data, that is like normal distribution we use. Okay, like
My project on site. So this thing basically works on very complex areas where you can never get data. Okay, so for example, if you have a very high heater, not a heater, like a furnace, yes. So the thing is, you can get a temperature of the furnace very easily, but sometimes you are also determining the flame, the color of the flame, right? Because those are the two things which are important. And so what you do in that case, either you take some information from an expert, incorporate that into the deep learning. You can take images of the flame, you can understand the sort of the bandwidth of the frame with that. And so that's how you get into more complicated. So the thing is that the fact that you don't have data is not a showstopper. And like you said, you can use simulation data. But what you can do is you use complicated algorithms to solve them. So I would some cases use something like Bayesian, for example. So Bayesian algorithms like that, which have some, where you can incorporate some element of prior knowledge into the algorithm. And I think people who are in statistics will be doing about Bayesian. And this is why AI is so complicated, because I'm shifting between artificial neural networks to statistics to Internet of Things to cloud and so on and so forth. That's why Oxford is quite complicated what we teach, but I'm trying to give you a way the world is in that way. So that's how I would solve the problem. Okay, any more questions before then I'll switch to IoT basically. Yes, sir. Yeah.
So I'm from biotechnology field. So I would like to know what areas you are working in niche biotechnology or bioinformatics. And our student, if they want to work in AI, what skills they should have so that they can go in this field and work.
So I think that I am personally doing some work, I did some work on drug discovery. Yes. So drug discovery essentially is the idea that you have a protein database or something like that, and you simulate other patterns and try to see whether the particular variant is a good medicine. I haven't done a lot of work on that, but one of my colleagues is amazing work on that area. And I have a lot of people and friends who are involved in that space. But in regards to this particular domain, it's a very hot domain at the moment, especially in the bio and the pharma areas with that. I think the best way to acquire skills is to learn to code and to look at a problem which you are personally interested in and try to solve problems. Yes, so this is what we are trying to do. And try to apply different algorithms and try to understand from there. The bioinformatics has got lots of public data sets which are great. So we start with that and look at track of computation and so on. Yeah.
As we know, the strong AI, that machine will work very intelligently than the human. But will it possible, or there is any possibility that the machine will overcome the human being in future?
So this is a whole question with Elon Musk and Bill Gates and all the people. Already to a certain extent that you are having is the way whether they are. And there was a slide which I skipped from there, and essentially that at the moment we are about simulating the brain of a cat. Yes, we can simulate artificially the brain of a cat. The idea is that by 2060 can simulate the brain of humans. Now, that's only one part of it, because simulating the brain does not necessarily mean that because it is just a set of neurons, doesn't mean that it's solved. But the way AI is solving, the rate at which AI is expanding is very, very interesting. Right? I believe that to a large extent, this will be a possibility of humans. So I think the first possibility is humans will work with AI. The thing about AI is that it is like, I don't know if you've seen the Star Wars movie where you have that clothing of the Sith warriors. We have one in it because they kind of like that. The problem is that it's just a copy and paste. Yes, so if you create one AI plus one is a copy function. So I think that you can train lots of them. They can go collaborate. Also, the rate at which AI learns would exceed that of humans because the more data it gets, the more compute it gets, the faster. That's why quantum is such a big one. The rate at which you calculate, which is faster. Yes, this is why AI becomes more interesting with quantum. This is how we do the work with it. Yes, for us, quantum is the computation. Now, the question about will humans be overtaken by AI, which is quite often a question people ask, and I take a very different view. I think to a certain extent, yes, but whether that is to be feared or not, that's the question. Yes, in my personal view, I think it is another technology which will fall, but the real concern. And I think this is something which people still not fully realize is today we have got two schools of thought. Yes, you have capitalism and socialism, yes, and both of them make people make for capitalism, make something for socialism. But if for the first time we could have something internet, it is evolved enough, right? And whether what does that mean, we don't know. So the answer is no. Okay. Now I will shift to Internet of Things because that's what we were going to talk about. Yes, which is second one. Now, sorry, for some reason this has gone not right. I got about 10. I got that 10 minutes more. Isn't it? Yes. Yeah, 10 minutes more. Okay. Yes. Yeah. So I'll talk about Internet of Things. For some reason, it somehow. So the way we view Internet of Things is we view it in the context of the cloud and artificial intelligence. Yes. So for us, you have edge computing, AI, and in the cloud. Right. So what we are looking at when we talk about Internet of Things, we're looking at Internet of Things such that they are intelligent to be able to run an algorithm. Right. Now, when you take that definition, you have a certain have. Yes. So I have a sensor for it. The original definition of sort of ubiquitous computing was around by the Palo Alto guys in about 1999, where effectively any sensor was able to connect to any other sensor. Yes. So you have something, I have something. I come into this room, it knows I am from the UK, it knows I am here, it knows I was yesterday. All that information sort of correlated to the physical space. But this is actually not a practical thing, right? Because all sensors have to have the same standard, they have to see each other, they have to be able to communicate in a common protocol, and they have to be able to operate in real time. This is actually a little bit of a future, sort of idealistic vision. I will not say futuristic vision, idealistic vision. The more pragmatic vision is you have devices which are capable of running something on their own and autonomously. So those devices are called edge devices, EDG, edge devices, yes. And an edge device essentially is something, as an example, could be Raspberry Pi, for example, yes. So it's capable of, has some capability to run something on top of it, but it is not pure sensor. You might have sensors connected to that. Then that device acts like a gateway device to a single sensor, yes. So the world of AI can be, so the world of IoT can be viewed as something where you have a capability, not as a pure sensor, but as a capability of running something on that device. And once you do that, it changes quite a bit, because that means I can train the algorithm in the cloud. I can put it in a Docker container or something like that. I can deploy that on an edge device. Okay? The edge device could be autonomous, meaning that it may not be connected to the network. So it would be able to run something, determine something. And it will be able to effectively send the data back to the cloud. Okay. So when I have an edge device or an IoT device, it also knows the context. So it knows that this is the temperature in the room, and it also knows the social context. I'm with certain people, I'm in a certain place, this is the ambient temperature, so that's the nature it knows. And it takes essentially time series data, typically time series data, right? Or image based data. The question is, to what frequency will you send it back to the cloud? Yes, you can do either a constant update, which is quite expensive, or you can summarize the data on the edge device and send it back to the cloud. Yes, those are the sort of two main ways in which you work. And then once you do that, you essentially train the algorithm in the cloud using the data, and deploy the trained algorithm to an edge device. We use Docker containers, but there are other ways to do it. You can do serverless, you can do a straight API, you can do many ways to deploy an edge device. The bottom line is that the device is connected, it is capable of running AI from our perspective. Yes. And the moment you do that, then there's the other side, which is the cloud. Because the cloud is where you train the algorithm, you get the data, because you can't train it on the edge device. However, there are some cases when you do try to train device on the edge device, that's also possible. But typically you train it on the cloud. Now there are some questions around these, for example, privacy, data, etc. you try to keep all the data on your device. So you don't set the data to the cloud if you don't want it to be very high. So in our world, IoT and edge devices, AI, this is generally the way they work together. Because what we are talking about is the capability of devices which can understand something and then can promise based on that. And but the intelligence of the device comes from the model which is created in the cloud and then deployed to edge device. This is generally the way the hospital is. Any more questions now for this? Yes.
This is the best algorithm for the crop disease detection.
What?
Crop disease detection.
Crop disease detection. So crop disease detection is a problem of, so it depends on how you detect the disease of the crop. Yes. So if it is a visual images, then it is convolutional image based. If there are some other characteristics for disease, for example, you might say that the crop looks, I don't know, you could say that there is something, something like that. So then you can do other things. Typically, it can image. Yes, sir.
Sir, will you please elaborate an example you are currently working upon, which is based on combination of AI and edge devices?
So there are many examples of combining AI with edge devices. The best one I can think of, the ones we are working on are to do mostly with robotics, for example. Yes, we have a robotic arm, and robotic arm like a cobot, like a small robotic arm. So you can train the AI in the cloud, and then you can pass it on to the robotic arm, and the robotic arm then learns some behavior. For example, it should learn to sort something, it learns to pick up a particular thing. You can train it in that. That's the best example, because then you can train this example in the cloud and then build the model and send it to the robot. The robot then performs.
Also, another question I have. Sir, what is the correlation between metaverse and AI?
So metaverse is obviously something which Facebook is talking about, but it's not a new concept. It's been around for a while. So from our world, from my Oxford world, metaverse is a augmented world, yes, where people are living and working with that. But we are trying to determine how to build such a world. Yes. So to do that, there are three examples we are moving forward. The first one is urban mobility. Yes, so we have data from. To do that, to simulate a world, you have to take data from the real world. Right? You have to take data from a complex problem which is dynamic. So we took data from London, which is the train station, train tubes in London, and we simulated that behavior of traffic, people, and so on with art. So this is one world which we are simulating. And then if you are then in that world, how do you feel and how do you react? This is the first one. The second one is simulating a world of engineering, where you build bridges and so on and so forth. And the third one was actually with the agency with climate change. So we're trying to simulate how climate change works over a period of time. So for us, the metaverse is a world which is based on real worlds from data. But once you are in that world, you will engage autonomously. So the AI is the link between the real world and the virtual world. Okay, and I think we have. Okay,
Questions from audience? More questions? Anybody?
सर एक असा एक आपला एक प्रश्न आहे की आता तुम्ही एक mathematics, statistics, electronics, किंवा computer या different specialization. They will be the AI is the combination of the flavor of the service. So that study biotechnology or the microbiology or the life sciences concern or agriculture field is concerned. So how can you apply the artificial intelligence? आता इथे जी थोडासा common आम्ही त्याला थोडासा मॉक बॅक केला. त्याला सराचा जो प्रश्न होता की सध्या त्यांच्या बायोटेक्नॉलॉजी मध्ये pharma industry मध्ये काय and they have to identify the problems. And if they have identified the problem in the life sciences, how they go to the proceed to artificial intelligence or the target how they use the artificial intelligence. That should go to the modeling, that should go to the algorithm, that should go to the mathematics. And again, some data is there. You have to classify the data. You have to make the frequency and the distributions, what are, let's say, the matrix forms and they will apply the neural networks, what type of the platform we are using the artificial intelligence, or where we are using the Python. That should be the, I guess, means objective of this workshop, objective of the meeting, objective of visit is that we have to develop some artificial models in the different places. तर अशा एक पद्धतीचं पुढे सांगितल्यावर आपण सकाळी काय करू शकतो कसं आपला कोरिलेट करता येईल फॅकल्टीच्या दृष्टीने प्रत्येक डिपार्टमेंटची त्या लेवलची ओके
आता For some reason, my slide वेगळी होती. For some reason, I thought I was sitting another set of slides. But I mean, Oxford मध्ये, what we are trying to do is to determine a framework for AI with cyber physical systems. A cyber physical systems चा प्रकार आहे is a very generic concept. कारण त्याच्यात तुम्ही म्हणा की बायोटेक्नॉलॉजी म्हणा इंजिनिअरिंग म्हणा they have some common characteristics. तर आम्ही ते basically number of levels वर determine and the framework म्हणजे असा की I can describe it in this way की आपण पेंटिंग करू पॅलेट असतो तर पॅलेट असेल तर तुम्हाला कुठले रंग आहेत त्या रंगाच्या थ्रू तुम्ही पेंट करू शकता तर दिस इज व्हॉट वी आर ट्राइंग टू डिफाइन what is a palette in whether you're looking at a biotechnology problem or whether you're looking at a agriculture problem. So you can then say that these are the possibilities. This is the use cases and this is the data behind that in a code way. This is what I'm trying to do. In fact, that is why